Well, thank you so much for coming to the Mono and .NET presentation. Some of you might have come to previous Mono events at the PDC, which were held on in a different way than the main hall. So I really have to thank first Microsoft for giving me a slot at the PDC. This is pretty unique. It's a pretty important conference. I've been coming here for a few years, and I've been a fan of .NET ever since it came out. And this is the first time that we talk at such an event about Mono and .NET. And also, especially Brian Goldberg, who works in the .NET group, and he's the one that made it happen. So I said, Brian, what about me talking about Mono and .NET? I was kind of poking Brian, and Brian said, yeah, we'll make it happen. So here we are today. Is this a clicker? Yeah? All right. So we're going to talk about a number of things today, and I wanted to give you an idea of what we're going to be talking today. So if you get bored, you can leave as soon as whatever topic, or you can leave now and then come later, or leave when your subject has been touched. We don't really have a lot of time to talk about everything I would like to talk to you about Mono. Mono, it's a really large project, and we've been working, with a large community of people, both organically in the Mono world and organic groups that developed around .NET, things that people that tend to gravitate toward AL.NET. And we really don't have all the time to talk about everything. But what I figured is, since I was going to put together this presentation, I was trying to put together a story that would be compelling. Tell a story during the talk and try to give some cohesion to it. Aaron says that I should be more assertive and not give these nuanced and presentations. But so I tried to put a story. I don't know if I did a great job, but that is what it is, and we're going to go through that, and hopefully you'll have fun, just like I did. So we are an open source implementation of .NET. That means that we started from scratch. We wrote the equivalent of the CLR from zero. We built it in C. We built the class libraries that go with it. So the system assembly, system XML, ASP.NET, ADO.NET, and so on. And we built everything from scratch. We are a subset of .NET because we really don't have the thousands of programmers that Microsoft has. Mono is an effort that is primarily sponsored by Novell, but many people in the community have helped us. So basically, what happens is that we build the core initially because we love .NET, and we also love Linux, and we're Linux users, and we kind of wanted to get this fantastic platform that Windows developers were getting. We wanted to get the same features on Linux and build our applications with Linux. That was really the intention originally. So we built kind of a stack that was useful for us. But as time went by, people started to find that interesting, and they started contributing. So a lot of the development of Mono is actually driven by contributors that need a specific piece of functionality or a bug fixed. And so we get basically patches from them. It's not any different than any other open source project. It grows to a large extent by what people decide to contribute to us. And also, Microsoft contributes to the project in the form of every time they release libraries under the MSPL, which they have been doing recently more and more, like Iron Python, Iron Ruby, ASP, .NET Ajax, and a couple of other libraries. We're able to take that code and run it on Mono unmodified without having to rewrite from scratch. So anyways, so we want to have a runtime that is compatible with .NET. There's a lot of advantages to that. The most important one is that you can continue using whatever tool you feel comfortable using, like Visual Studio, build your application with that, and execute the resulting code on Mono. In fact, one of the things that we're building right now, and it's not ready for public consumption, is a plugin for Visual Studio, so you can debug directly from Visual Studio a remote Linux system. It works, but it's terribly complicated to set up right now. We'll fix that. So anyways, the Mono universe is kind of large. As I said, we implement many of the Windows APIs that you guys are familiar with, Windows Forms, ADO.NET, ASP.NET, Link. But we've also created a pretty large ecosystem of APIs. And as I said, we're not really going to talk about those things. We could talk about for days about APIs. And instead, I'm gonna kind of focus on a couple of things that I think are interesting. But I put up this picture in case you kind of wanted to get an idea of what's out there. And you can Google those up and use it in your app. What is interesting is that we've tried to make most of our libraries cross-platform. So that means that pretty much everything that we build, with a couple of exceptions, works on Linux, works on the Mac, and works on Windows as well. So everything that we build, we try to make it work on Windows as well, and you can benefit from that directly. Now, of course, what we want to do is basically bring .NET to where .NET has not gone before. So in a sense, if you ever are faced with the problem that your software needs to run on another operating system, you don't have to go and pick, you don't have to rewrite your software in Java or pick Python or pick, some other platform. We want to make sure that you can keep using .NET and using the libraries that you're happy using with. And of course, we support Windows, Linux, and Mac. What is interesting, though, is as it turns out, many people use Mono on Windows. And I'll show you a couple of really interesting scenarios. Probably the most exciting one. Anyways, we'll talk about that in a minute. And of course, we've also brought Mono to embedded devices. The SansApp MP3 player runs Mono. The iPhone runs Mono. And I'll talk about how we do that in a fully legit way. No jailbreaking. It runs on the Wii, and at least one game company has ported it to the Xbox and the PS3, which, since we're not yet approved developers for those two platforms, we can't do the port. They did it, but we're approved Wii developers, and we did the port to the Wii, which is only available, sadly, for approved Wii developers. So anyways, pretty exciting. Last week, I went to a conference that specializes in gaming, and I saw the first 3 games built with Mono on the Wii, and they're beautiful. They're kid games. So. And the contract with the other company prohibits me from telling you which big blockbuster game is built with Mono and runs on all platforms, and specifically on Windows, which is one of our big users. But anyways, I can tell you privately according to the contract. So I just can't say it on stage. So Microsoft has one thing that has happened that is fascinating is Microsoft has the source code of the CLR, and this really goes to the core of what makes open source tick. Microsoft, owning the CLR, can actually take the CLR and adapt it for really interesting usage scenarios, right? So they adapted the CLR to run inside the browser, and they call that the core CLR. They're also using it for mesh, according to a blog entry by Scott Hanselman. I'm not 100% sure, but that's what he said.
He's right. I pointed it out.
Oh, all right. He is right. So Microsoft is in a position to taking the CLR, which I think is a fantastic technology. It's a fascinating VM, and we'll talk about that later. But they're able to do these fascinating things, but really nobody else is. So what we like that is happening with Mono is that people are really customizing Mono for using it in really interesting ways, in the same way that Microsoft does it today with those other platforms. So over the years, right, initially we just built a CLR, and we just built the class libraries that were very similar to .NET in spirit. And people have told us, well, we really want to replace this chunk. This is kind of bloated for our scenario. We want to replace the GC. We want to replace the JIT engine or the compilation engine. So we made Mono modular. So you can actually at configuration time, you can instruct Mono which pieces you want from the runtime. So you can actually pull some of these pieces out and plug other pieces in. So it's a modular runtime. We can go from the the full Mono distribution and compress, which is roughly 100 megabytes, to the minimum, the tiniest version that we've produced is a 2 megabyte version that is still useful. So now I'm going to switch a little bit to our compiler. Our C# compiler. As it turns out, when Microsoft came out with .NET, I was fascinated by the language specification that Anders put out, and I really liked the language, and I figured I would learn C#, and the only way of learning a language was to write a compiler for the language in the language. So I took Anders' compiler, and I built a C# compiler in C#. It took about 6 months to get the compiler to actually bootstrap. as I was learning the language, and it was incredibly slow. In 2001, the first time the thing bootstrapped, it was made up of about 10,000 lines of code, and CSC was able to compile it in roughly a second, and it took our compiler 17 seconds to bootstrap. It was incredibly slow. And as it turned out, it was all about string allocations. We were concatenating tons of strings. And once we got rid of that, we got the performance back. But it was mostly that. Today, the compiler, this is really interesting. The compiler today compiles 82,000 lines of code in my laptop in 2.2 seconds. And it's, it's 1.6 times slower than, well, it's actually 60%, no. We're 40% slower than CSC, yes. So last night, Aaron forced me to do the test. He's like, well, how fast it is? Like, well, I don't know. I'm like, well, why don't you test it? So we had to. So it turns out that we're not bad, considering that for our compiler to compile itself, first it has to load the CIL bytecode, then JIT that code into native code, then load the code, the source files, and then generate the new CIL code. So it's not bad for a managed compiler. And a couple of months ago, I was having a discussion with Marek Safar, who's our C# our maintainer. I no longer work on the compiler anymore. Marek does. And we were talking about turning the compiler into an evaluator and reusing it very much in the same way that Anders did. So we built this a couple of months ago, and it works. So let me show you how. I don't know if you guys really care about seeing it, since Anders already showed that. But prove it. All right. Let me just find the right connection. Oh, there we go. So this is my IDE. Again, I was going to use Emacs because that's what I use, and I'm an old man. So system dot no, what do I want to do? Object X equals evaluator dot evaluate. Right, and there's a bunch of different overloads, but I'm just going to use a very simple one, 1 plus 2, and then I'm going to write the result. And there you go, 3. Very exciting, very exciting. Thank you, thank you, thank you. Now, of course, anybody can do 1 plus 2. I mean, I could have cheated. So when we built this, we think that this is fascinating. You can build read-eval print loops, just like Anders was talking about 2 days ago. In fact, some of this discussion came by because my best friend Nat Friedman was raving about Ruby on Rails and how he never actually wrote code directly. He kind of prototyped it always in the shell, and then he pasted it. And he didn't really understand a lot of the Ruby libraries, so to him it was a way of exploring the language and exploring the framework. So he said, you guys really should have a real-eval print loop. And I said, I bet we can do it. And so it took about 2 weeks to reshape the compiler into a real-eval print loop setup. But we think that there's a lot of really interesting applications. Like, for example, you could script your apps in C#. And this sort of goes to a discussion that they were having today about DSLs in the programming panel. They were saying, well, we need a DSL for handling this specific scenario, that specific scenario. And I think that at least in a lot of the scenarios, what happens is that you don't really have a good language to parse your stuff, so you end up inventing these really bad, tiny micro languages, by parsing a file or just parsing some things, and you end up with what looks like a language, but it's not really a language. So what you can do with this thing is actually you can configure your application like Emacs does, right? Emacs configuration itself is written in the language that Emacs implements. So you don't really have a file with settings. You actually execute code when the application starts up. So you really have a powerful configuration language. Emacs is not alone. A lot of applications based on Python these days, instead of having a config language or a config file, what they do is they just source a piece of Python code. And then you have a lot of things, because you're not limited to setting values, numbers. You can set hash tables, you have properties, classes, and you can do a lot of interesting things. So anyways, we think this is really interesting. So what we did is we built the C#, a C# command line compiler, right? And which one was it? This one. So this is a lot. This is better. So basically, I don't know if you guys can see. Let me do this. Edit. I think I have to do this. What? Oh, change profile. Hold on. There we go. Change profile. Oh, there we go. OK. So this is my my dingus. So I can, the same thing that I did before, or I can say hello dot index of L, and that should give you 2. Or you could do more interesting things like link using system.io. And this is live, so I might make a lot of mistakes. From x in directory dot get files, etc. Where x ends with, in Unix, all the configuration files on the system ends with the word RC. It stands for run commands, and it was, it's like .bat. No, it's not really like .bat. So select x. So those are all the configuration files in my etc. directory. That's the equivalent, really, of ls, etc. RC, but it's done in a real language. I don't know, what else can I show about C#? I had a canned demo, and I can't remember what it is anymore. Anyways, never mind. So the other thing that we did is we figured, well, this is really interesting, but I'm sorry if I'm using the command line. Aaron is probably going to be very upset with me because he said I shouldn't do that. But let me show you this other one. This is the exact read eval print loop, but the difference with this read eval print loop from the past one is that this is actually integrated with the main loop, the windowing main loop. That means that it's processing events from the GUI, and I actually can create interactively applications. So I can say load package. This is our library that we use on Linux for doing GUIs. So, and then I can do using GTK, and I can say window W kills new window, hello PDC. Then I can create a button, click me, just like Anders did. Then I add the button to the other thing. Then I can add an event handler, just like Anders did. I was clicked. I forgot a semicolon. As you can see, it also has completion. If the statement is not complete, very much like Python or Ruby would do, you actually have to complete it will use a different prompt, which is, it's this beautiful yellow prompt indicating that the statement is not complete. And then I can do a wshowAll. In GTK, you have to call this method before. So there is my window. You have to actually call that method before the stuff will show up on the screen. So when I click it, it says I was clicked. I could do something more interesting like well, I get b.label plus equal, actually, int I equals 0. So b.click, delegate, b.label, I have been touched, I plus plus times. That sounds all right. Yeah, well, that was a little bug, but. Now, the other thing that we did is we figured, well, now that we have this thing, we could actually render, if some of the results, actually, like, for example, if we say new hash table, does somebody remember the syntax for this? Key 1, value 1, key 2, value 2. So we actually have a special renderer that detects that this is a hash table, because by default we call toString on the object, right? So when we get the object back, we print it with toString, and the hash table would, the string or hash table is not that interesting. So what we do instead is, well, if it's an IEnumerable or a hash table, so we have a couple of, I think it's dictionary. So we handle a couple of things like that, or IEnumerables. That's why the select statement, instead of rendering a horrible, link type, actually renders the results. But what we did is we had with the GUI version, we could actually handle a couple of other types. So we can say system.drawing. I have to prefix it because I've imported the GTK namespace, which means that the image class actually conflicts with the GTK image class. So I have to do a full prefix for this. So just ignore that. So I can say image from file, and then I can load an image like moon.jpg. I conveniently place that file before I came. So, the image shows up there. Now, of course, and we did a couple of other things. I wrote this is a 5-minute plotting function, so, you have to go easy on it. I didn't really spend a lot of time on that. But basically, we have a function that takes a delegate. It takes a double, and then the double result will be plotted. So you can plot, for example, a very simple linear function, very simple. or we could say, I don't know the name in English actually, a parabola, or something more interesting like, thank you very much. Math.sin of x divided by 10. Or you could plot a bunch of these functions. Actually, these would be cute. And then I can add another one that does so anyways, all this is doing really, and there's not a lot of magic. All that plot is doing is really, it creates a system.drawing.image, and it goes from minus 100 to 100. That's what I said. It's not very sophisticated. It goes from minus 100 to 100 and plots the function values, and that's it. That's really what it is. What is interesting, actually, is that somebody was mentioning, well, since that's a GTK widget, what we need to do is a provider model. So every time you get an object, if you can get something that can turn into a GTK widget, you should render that GTK widget. So we could probably do something like the link pad. We haven't done it, but we could do something like the link pad where when you get a link result, we could actually render a proper table that you could edit and inspect and so on. Anyways, so I think I'm getting distracted. Is there anything I need to show you more about my C# eval? Yes, it's available today, so you don't have to wait until 2012. So it is available today. Pretty sweet. So let me just go through. Well, I had a bunch of examples here, but obviously, system XML linked to blah, blah, blah. But I figured it was better to do it live, like Riley said. Now, here's something interesting, and this is just an excuse. This just gives me an excuse to tell you about the other feature, another interesting feature in Mono, which is the Mono linker. The compiler API, as you can see, the compiler originally was designed as a standalone application, and that means that absolutely everything in the compiler that was by default public, right? So public class if statement, public class switch statement, public class binary operator, and so on. And there's certainly some private things, but for the most part, it was a public API, and we didn't feel like if we were going to ship this as a library that people would use, that we would be doing people a disservice by exposing everything in the compiler without actually carefully reviewing what needed to be exposed and what did not need to be exposed. So we decided on a very small API. We wanted to have that very tiny, well, actually, the font is too small, but basically there's only 4 classes exposed, the evaluator, a couple of callbacks, and a couple of other things. But we wanted to basically come down with a very minimal API, but we also did not want to edit hundreds of files and turn everything into internal, and in the process destroying the revision control system history, because everything would be attributed to someone else. So what we did is we used a monolinker, which is a tool that can manipulate assemblies. And it's actually a very extensible linker. We can do a lot of things with this linker. One of these things is reshaping assemblies. There's a number of steps that we can provide. And one of these steps is basically hide every member that is not listed in this definition. So we have a little definition file that we provide to the linker, and we say, this is the public API that we want based on this gigantic monster. And it generates our Mono C# assembly with this very, very minimal API. An API that we feel we can support, and we wouldn't really hurt anybody if we support it that way. So we didn't want to. So let me show you just so you get an idea what that link file looks like. So again, let me change this thing to so you can read it. There's anyways, CVS, MCS. Where is it? Tools, C# library, and the link file is this file. And as you can see, it's incredibly simple. I just tell it what are the public APIs that I want exposed, and it will expose all of those APIs. And I can fine tune it. I can say, well, this turned and protected, this one don't do it. But this is a very simple definition. And you can see how this is used in my make file, which is, yeah, just never mind. It's very easy. Oh, here it is. Here you go. That's the invocation. And then we have to sign it to put it on the GAC. SN is the thing that puts in the GAC. Where was I? Yes. So the monolinker, as you can see, there's a couple of steps here. The ones that I want to highlight it is we gave it this link file, but we also run adjust visibility. That's one of the steps, and it comes out from an assembly. So you can actually configure the linker, and you can do a lot more than just hiding stuff. And I'll tell you what we use it for in Mono. And I think that there's a lot of more uses that you can use. A lot more uses than that. So. Some of the things that we've done is we've basically shrunk assemblies. We've taken really large assemblies. Remember that I told you that Mono was very easy to customize for specific scenarios. Instead of going with an axe and chopping the source code, peppering it with if-defs everywhere, what we do instead is we create these definitions, and we can shrink, system XML to just the things that we need. And you can deploy those things in an embedded scenario, or you can take, very large libraries, and if you only need a couple of types, you can extract those types and put in your applications. So that's one use. Another use that we think it's interesting, but nobody has done it before, is to create your own compact framework. One of the things that happens with the compact framework is that Microsoft basically had to balance, a general purpose framework with the space that they could put on the device. So they had to choose, we're going to include these types, but these ones we're not going to include because, well, they're not general purpose. And people come back and say, well, actually, I really needed, what's the one that the people? Reflection and myth. That one. So. What, did I have that at the tip of my tongue? So, a lot of people kind of, they're, they would like to have their own compact framework. And if you had a Windows device, Windows C device, and you could just replace your CLR with the version that you needed, you could do this sort of thing. So basically, people could do that. We do that in a different scenario. Our Silverlight implementation actually takes our full .NET 3.5 API assemblies, this complete API, and we fitted a bunch of linking description files, right? It's a much more complicated command line than the one you saw, but it's essentially the same process. And we shrink those to the Silverlight API. There's a little bit of fine-tuning that we have to do, but it's very limited. We have like a dozen of if-defs, but it's very, very limited tuning in the source code that we have to do. And that's how we generate our .NET 3.5 APIs. People use it also for a lot of other things. The linker and the infrastructure upon which it's built on. And again, all of this stuff works on Windows, so if this is useful to you, you can just copy it from our website and stick it in your app and use it in whatever way you want. Now, this brings me to the most to what actually we feel is the most fascinating piece. What is interesting about virtual machines is that since the CIL code is not really machine code, it actually contains all this semantic information, your methods, the name of the parameters, the names of the classes. All this rich information is preserved in the DLLs and the executables, and and so far, and there are tools like FXCOP that actually inspect these DLLs and actually can make recommendations as to things that you can do, things that you can change, fix in your code. It's really useful. But what if the virtual machine could also do some interesting things with all of this rich information? Microsoft already has done a lot of that. Garbage collection. You have precise type information. You know what things you JITed, how you JITed them, right? So you have that. The runtime can provide JITting facilities and so on. But there's a lot more than you can do. And the situation is that most virtual machines are the features that you can put in a virtual machine are really bound by a number of, just by reality. Microsoft might not want to put the feature in because they don't have time, because it's not, it would take 8 years to, get it through the proper process, or it's not, it's not useful for the general population, or, just there's no, all kinds of reasons, just like your software product. Why don't you add every feature possible in the world? Well, there's a lot of realities to that. So what has happened is, that a few people that use Mono actually, again, this goes back to the core of what is interesting about open source is, well, the fact that we're not willing to put the patches in doesn't mean that they can't put the patches in. And if we have time, I'll talk about, at the end, about some of those things that people have done that we haven't taken in because they're not really general purpose, but they're really interesting nonetheless. So we built a couple of ones, and I want to talk about some of those things that we've built. One of them is this idea that we borrowed from Java, which is a virtual machine API. And And again, this goes back to my friend Nat, who was raving about Ruby, and he said, you know, what is really interesting is with Rails, when you have the deployed application and there's a bug, you can actually attach to the running process, and you know, there's a shell. You send commands to it, and then you can inspect the state and, you know, make some live changes and, you know, fix the database or something. So we implemented this feature, and what happens is there's this API that you use. It's called mono.attach, and you give it a process ID, an assembly, and it injects the code in the other assembly, in the other process, and then the other process spins it up on a new thread, runs the code, and goes on. So let me show you a real-world application of that. Oh. So this is, again, this is the same interactive shell that I showed you before. And what we're going to, oh, yeah, sorry. So this is the same interactive shell that I was using a second ago. And we've extended it so that it can eject itself into another process, right? Because, you know, not everybody's going to add an interactive shell to their application. So we can actually force our way into every application on Linux desktop that is using .NET, and we can inject an interpreter. So I know that Don Bock said that demoing, you know, photo applications is lame, but you know, I had to come up with an idea, and this is my actual photo gallery on my laptop. So this is not a fake photo gallery. You know, this is me, and anyways, well, whoa. This is my niece. Of course, my mother was taking the pictures. There was a lot of alcohol had that day. But what I wanted to show you, how do you go back to, oh, they changed this UI. Anyways. Oh, damn it. All right. So let me just get this. I have a wobbly effect system. What is going on here? Damn it. I don't know what is going on here. I apologize for this. All right, never mind. So we're just going to let that window do its thing. It seems to be a bug in the photo application. This is a photo. It's not my fault. I didn't write the photo app. So anyways, so it's not my fault. All right. So. Oh, I could try that. All right. So when I say file attach, it actually uses the getProcess API, fetches all the monoprocess on the system, and the machine is actually slow because I don't know what that thing is doing, but we'll attach to it. So now it actually started up a new process. It inserted itself. Now it's actually slow. I don't know why it's doing that program. But anyways, now I'm attached to that, and I'm actually running on the target process. I didn't write the code, so again, this is what I gathered just from looking at the source code for 5 minutes. But so, for example, I can say core.database, if I can type it, right? So I can say d equals core.database, and then I can say describe d, and that gives you an idea of the API they have. And then I can see d.photos, and then I can say d.photos. What is it called? Total.photos. And that should match the number of, if I can get the window back up. Well, it seems like I won't. But where is it? Oh, there it is. There it is. You can see it. It's moving right there. I also want to apologize to my friend. Thank you. I want to apologize to Aaron because he said you should demo my app, which is actually stable, which is a music player. And I couldn't actually fetch your sample file. The URL you gave me was wrong. Anyways, so let me kill this thing. How do you kill this thing? So actually, I could probably call application using GTK, and I could say application.quit and just force it to die. And I guess it's dying. Anyways. Die. Anyways, moving on. Again, not my fault. That photo app fault. So what else? So we thought that was pretty neat, and we actually borrowed this from Java. So Java has the same API, and you know, Nat came up with this idea. And actually, we had a couple of people request it. We just never thought of any good use until we had this idea, and like, oh, that's really good. So we implemented that, and you know, this is the same demo that I just did. Now, let me switch gears and tell you what has been happening with mono in games. As it turns out, there's a really interesting use for mono in games. And let me give you a little bit of background. Typical games are made up of, they're relatively complicated applications. And you know, you have a display component that has to deal with a lot of things, like you know, talking to the GPU, doing vertex shaders, pixel shaders, you know, dealing with that sort of thing. There's a simulation layer that deals with physics, particles, collision detection, you know, mesh collision detection. Then you have another component of the game engine, which deals with the AI, like how do the enemies behave, the animations in a game, what kind of things you're animating or not animating, or the lighting, or you know, or all of the decorative stuff. How to track, how does the camera track you, right, in response to objects in the room and so on, and you know, dealing with audio input and networking, and what happens. You know, a game is it's an engine that it has to render between 30 to 60 frames per second. You know, it has to take user input, has to take network input, it has to run the simulation, you know, figure out where objects are. If you throw an object, where's the next position, where it should appear on the screen. It needs to invoke all of the enemy's AI, and the enemy needs to make a decision on a given position, right? It needs to do all of this stuff. And eventually, you need to push this to the rendering pipeline and the audio pipeline and update these on the screen. And you have a very short amount of time to do it. Now, there's a number of techniques that you can use to improve this. Like, you have multiple threads, and one thread will do AI, and you know, things are going to lag a little bit behind. So there's a number of techniques. But one of the problems that people were talking to us about was the fact that turns out that a lot of games have limitations on how much AI they can put on a game, because it's the slowest piece of everything. So as it turns out, both the display, the simulation, and the supporting infrastructure tend to be built on C, C++, or assembly language, right? So there are people tuning shaders, there are people tuning the physics in C++ using templates and that sort of thing. But when it came to the game logic, this is not something that you want to write in C++. This is something that you wanted to keep high level, right? You wanted to have a different team of people actually build that. So you have people that graduated from MIT doing the graphics and the simulation and the physics. But you want an artist to actually be tweaking the behavior of the light, and you don't really want those guys tweaking your C++ code and then overwriting or forgetting to free a blob of memory. So you give them a safe language. And what has happened in the game industry is for the last 8 years or so, people have adopted Lua in droves. Lua is a scripting language. It looks like C. It's very easy to embed, but it's also relatively slow. So people build a lot of games. Most of the games that you see in the industry today use Lua or use Python or some other scripting. What is the other name? The famous one that is bundled with the game engine? Unreal Script. So all of those are scripting languages. And so we were contacted by people that wanted to improve the performance of their games. And you have this whole range of things, right? So the safer the language is, right, the slower it is, just because it's easy to program, but then you lose on performance. And if you go to assembly language, it's incredibly fast, but you don't get a lot of the productivity really plummets. So what happened is that C# and Java really hit a very sweet spot, and in fact, many of the managed languages do. So as I said, Mono is incredibly useful for embedding. And move. All right. So what has happened is that a couple of companies have started to switch to Mono as their scripting language. A couple of years ago, Second Life, which is a massive multiplayer online system, simulation system, started work on replacing their own homegrown scripting language called LSL, and they switched to Mono. And it gave between 50 and 300%, depending on the test, performance increase. It is interesting because actually, they finally deployed it in late August, I think. So it finally went public after a year and a half or 2 years of development. It finally went public in the Second Life grid in late August. And they actually had to make monoscripting an opt-in feature, because a lot of the script developers that were developing script for the world actually were depending on the script running slow for a lot of the effects. So you actually have to opt in. When you create your script in Second Life, you actually have to opt in and say, well, I actually want to use Mono because my code runs fast. I mean, or does proper timing, or whatever's the case. The other case that is incredibly interesting is a company called Unity 3D. And Unity 3D powers the Cartoon Network's Fusion Fall, which is a product that was either launched this weekend or is launched the next weekend. It's an online gaming system for kids. As much as it pains me, it only runs on Windows. So it's a use case of Mono only on Windows. So you'll see it. It's a really gigantic MMO. Massive multiplayer online game for kids. It's made up of 256 universes. I saw it last week. And when you put a lot of production money into this thing, it looks really pretty. And what Unity does something really interesting. They script a lot in C# and they script a lot in Boo. But they also script in this JavaScript-like language called UnityScript. UnityScript is identical. Well, okay. So UnityScript is JavaScript, except it doesn't support prototypes. It only supports C#-like classes, and it is strongly typed. So it's not like JavaScript loosely typed. So it looks and feels like JavaScript to most people, but it's actually strongly typed, and that gives them the performance that they need. So let me show you Unity because I think it's fabulous. Where's this thing? So the idea, and this is another interesting thing. Unity was a product originally built completely in Objective-C. It was incredibly tied to the Mac. And the only thing that they did is they used Mono for their scripting. So this is the game. Let me give you an idea of what this looks like. I should have done it full screen. How do I do that? So this is an IDE for building games. And I can walk around this thing. And there's supposed to be audio here. Can we get the audio on the... Because there's some birds flying around me. What? Oh, there you go. So you can see those birds, and each one of those birds is controlled by a monoscript, C# or JavaScript. I can't remember. So I can hang around on this island, and actually, there's a dude that I know where it's hiding that actually runs from you when you approach him. So I'm going to show you that. So one of the interesting things, this guy, you see that guy? He runs scared. Now, they've actually done something incredibly interesting with Unity. Let me get back out of full screen. Let me get it out of that. One of the things that they did really is that they actually reevaluate your scripts as you build them. So you can actually make changes interactively to the game, and the changes get reflected immediately. But as I was saying, this application was originally built entirely in Objective-C. It only ran on the Mac, and Mono was merely the scripting engine. And what happened is that it turns out that the game industry is mostly Windows-based. So they actually rewrote the entire application into C#. And now they showed it last week. It hasn't shipped yet, but they showed it last week, and it will be shipping on Windows, so you can start building games with this thing on Windows as well. So let me give you an idea of what this language looks like. This is UnityScript. As you can see, well, you can see there yet, but it looks like JavaScript, and people familiar with JavaScript will feel familiar with the environment, but it's actually strongly typed. And it also has a couple of extensions like yield. So they added the yield keyword here, which basically allows the program to suspend execution and then resume execution at that point on every tick of the game. This is a very common pattern for games. So you can write code like, for example, wait for enemy, semicolon, attack enemy, or while waiting for enemy, attack enemy, that sort of thing. So, let me show you something quickly here. I added this spotlight to the character, so it's a spotlight similar to the one in Half-Life, the one where when you turn on the light, you can see the light there, and I can write a little script that would make the spotlight scary. So what you do is you create C# script, or I can create JavaScript or BootScript. I bet you that's just BootScript, just called JavaScript for marketing purposes. So what I'm going to do is I'm going to create, I'm going to control the spotlight here. So what I do is I basically create here a public game object light. And then on every update, what I'm going to do is I'm just going to turn it on and off. So it's like, is it enable or active? I think it's active. Now, you may notice that the API is not exactly .NET-ish. And the reason is that when these guys built the bindings, they had not read Brad Abrams and Christoph's design framework guidelines. So there's a lot of things that they did in an interesting way. Like, for example, they have an implicit cast operator from mono behavior or game object to Boolean. So instead of having to do if val different than null, they just write if val, like as if it was C. So anyways, they didn't really know what they were doing. But they're good guys. They're good guys. So now I'm going to save this function. I'm going to save this guy. And now I need to attach it. Oh, actually need to, well, I'm just going to do this. I'm just going to attach this guy to the to my first controller, which is a character that is playing. And the one thing that is important is that the light, which was the game object, the variable that I declared, needs to actually point to the object, to this object. Actually, if I try to play the game, you'll see that there should be an error. Right, you see I get a null reference, an unassigned reference exception. So that's the problem. So what I need to do is I need to drag the spotlight. Oh, no. Where's my script? Oh, here it is. So I need to drag the spotlight, which is the game object, into the light objects, which is what I'm controlling. And this should basically blink as I go. You can see it blinking. And every time, and every click, it's basically turning it on and off. So, we can do something more interesting with that, like, where did I put it? Where was it? Oh, God, where is it? I can just edit it here. So you could say something like, instead of making it like that, you could basically say random.value. And again, they didn't know, you have to forgive them for that, bigger than 0.5. And that should give us a little bit better behavior. So it's going to be not as bad. But the reality is that we're programmers, and we should not be doing this stuff. So we really should let an artist do it. And I think that this is really cool. So we basically say float rate. And then I just declare that as a float. And then I do this, rate. I save the file. I go back here. And the property should appear here. So I should set that 0.5. So that gives me that effect. Or maybe I can say 0.9. No, so that's too bad. So maybe we want the light to be on most of the time. So it just, it blinks like that. A little bit more scary. So anyways, so this is a really interesting use of mono, and we really like it because this is probably the nicest demo. When we show an ASP.NET application, people go, "Oh, all right, HTML." But when you show them this stuff, it's like, "All right, now we're talking." So where am I? Okay, also I did that. All right, so now we were talking to more people, and they were telling us, well, this is the traditional model, right? So the game AI is all scripted, and that is the slow piece, right? Well, our game engine is compiled, right? It's very fast, but it's hard to develop it. And the graphics engine, again, is the same thing, right? So what we've done so far with Mono is, did you notice my smooth transition? What we've done with Mono so far is basically we've managed to get the game AI to be faster. And so we let people be faster in that particular case. But we were talking to another game company, and they were telling us, you know what? We have been using C# for the entire game on the client and the server. And it actually has improved our productivity tremendously. We're actually way ahead of schedule than what we would have done with C++. But there are actually a few things that are killing us, because these guys are building both the game AI and the game engine with C#. They're not building just the AI. They want to go beyond that. The game engine is the one that takes care of your physics, the one that needs to update objects' position. It's just not the high-level stuff. It actually goes a little bit deeper. And it allowed them to improve their productivity tremendously. So we were talking to them, and we're trying to understand how we could improve that thing. And basically, the scenario where we want to go is basically to make a reality the fact that you can use managed code for the game engine. And they do have this managed engine. It works passively today. And we implemented a feature for them that is actually incredibly useful. And so I need to give you a little bit of an idea of what's actually happening inside the game engine. So what happens in the game engine is that for every object that you have on the screen, you're going to have a mesh that describes it, right? So 1 point for each, every point of the guy, right? And if you're going to move the arm, 10 pixels, right? You need to move each one of these points. Each one of the points needs to move in space, right? And it's a 3D vector, so it's not just this direction. It can move in any direction, or an object in the world. So that's a very simplified version of how you would update the position of an object. You pass an array that contains all of the points. You pass a delta that contains the actual difference. And it's very simple. All you do is for each point, you actually change it by the amount that you want it to change, right? Very simple stuff. And for those of you that appreciate my PowerPoint skills, I have the summary of what that's actually doing as a matrices. And the way you implement the actual addition operator in C# is the thing that you see below. You have a vector class, and you define a vector operator that takes 2 vectors, and basically it returns a new vector with the addition of each one of the components. So a.x plus b.x, a.y plus b.y, and so on. Now, this is what the IL code looks for the update method post, for the update post method in IL. The section in blue is the one that I want to call your attention to, and it's the one that actually is making the addition, right? So we load the values, and then we call this method that performs addition. You'll see that I'm actually cheating, and I'll explain to you why in a second, because this is not vector 3f, it's vector 4f. So that's the method that we call, and the implementation for that method for vector 4f.op addition in IL, and this is the exact implementation that you will see in things like OpenTK, which is an open source, it's a toolkit for building games. Did I get that right? Yes. And this is roughly what the IL code for that is, right? It's basically, the exact same thing that I showed in C#. And that's what the mono runtime generates. The blue component is the actual piece that loads all the data and calls the OP addition method. So there's a lot of junk happening there. So what we did is we modified the mono virtual machine to actually detect this particular call instruction, OP addition. And in fact, we capture a lot of things. We capture everything that can be emulated on the Intel SEC2 or AMD SEC2, SEC3, SEC4 CPUs. And we basically, so we have addition, multiplication, dot product of shift, move, fill, shuffle, all of the operations that you have in SEC2, which are incredibly useful for gaming or video or media processing. So we capture those things, and we generate a decent set of assembly language, which is that. So remember the pages and pages of code that I showed before. They turn up to be 4 instructions. Now, the really nice thing is that we wanted to do this thing, and I told my JIT guys, and I told Paolo, please implement this thing. And Paolo was like, oh, actually, garbage collector, I have to work on that. Reflection has a bug, I need to work on that first. And he wouldn't do it. And one of the other JIT guys, Rodrigo, one weekend told me, well, my wife is going to be gone for the weekend, so I might, I'm going to take a look at the SIMD idea. So I said, yeah, sure. Here's the spec. So I fired off the spec to him. And on Monday, we had a working SIMD operation, the first one, just one, right? But we got it by Monday. And he's been working on it for a while now, and now we support, a collection of tons of things. Oh, you're not supposed to see that yet. We support what? Vector 4F. Well, we support everything that SEC supports. So 16 bytes, 4 floats, 2 doubles, unsigned integers, signed integers, and all the data types that you can get with SEC. And then we decided to benchmark this stuff. And with the simple benchmarks that Rodrigo built, he just put a bunch of loops and sums and multiplications and stuff like that. And these are the results of comparing. All of these results are in Linux. So this is MonoSIMD using our classes on aligned data structures compared to the Java implementation of this code compared to the regular floating point that Mono does. So as you can see, Java does a little bit better than we do on floating point on Intel. But when you're using our classes, we are massively faster, 3 times faster than Java in that particular test case. The other thing that is interesting is that when I actually decided to port a real physics computation, instead of just a loop of additions. So this is a port of a very simple acceleration simulation. In the first case, the linear one, and in the second case, it's a physics simulation that does a spring and gravities, right? So you have a little bit of a spring effect and gravity involved. And it turned out that in the most complicated cases, like spring and gravity, the performance difference was massive. The plain implementation of Mono was 17 seconds versus 1.7 seconds. So it seems like these operations compound once you're doing these kinds of things. What is interesting is I did not try to optimize this code. This is a straightforward port of the code that is found on that URL below, which is a really interesting blog about a guy that is trying to learn to build games using F#. So it's a really interesting blog to follow. And the guy actually complains that it's incredibly slow with all of his genericized types, and he goes on and on. It's a straightforward port. I didn't try to optimize anything, and that's his C++ code versus my straightforward SIMD port. And I can actually show you that stuff live. If I remember the directory where I put it. Oh, look at that. Kill all. No. Spot. Okay, got it. I just don't remember where I put it. Oh, there it is, SIMD tests. And again, I need to do change profile presentation. So there's a couple of other simulations that I have there, like Rungecut and so on, but let me see which ones are the good ones. Simple 2 is the more complicated one. So if I turned off SIMD on the Simple 2 executable, I should actually time it while I go. It's doing some physics calculation. It does tons of loops, and it runs it hundreds of times, so we can actually get some interesting measurements. It's taking a little while. You guys can ask questions in the meantime. You don't look like yes? Yes, it is. Well, it's in open source we call that trunk. So it is, but it will be released. It will all be part of Mono 2.2, which is released in the first week of December. So the Microsoft people said, if you're gonna, there's a guideline for the slides. If it's gonna be out like 9 months away, you use a blue slide. But if it's gonna be like next week, it's gonna be a black slide. So I'm all black. So there you go. That took forever. I don't know how many seconds. 48. That's horrible. Jesus. Okay. And then if you run it with this one, please work. Oh, there we go. So pretty sweet. Anyways, now ideally we would love Microsoft to. I think that we were never expecting this kind of performance gain, specifically when we knew that maybe 3 times would be the best we could do. And we also know that C++ compilers do support this intrinsic. So actually, if he were to port his the second line, the C++ code, if he were to port it to a compiler-specific extension to do the exact same thing with the compiler, he would probably be a lot faster. But what matters here is that we wanted to basically make managed code safe for games, right? So I think that's a pretty useful goal. And of course, we would love if Microsoft, took MonoSIMD or we work together in having system.simd or something like that and put it in ECMA or something along those lines. we were surprised that the results were going to be so good. I mean, that's why it was kind of a weekend thing. It was, well, let's see if there's any real benefit out of this thing. And it turned out that the gains were pretty impressive. The other thing that I wanted to show you, and how am I doing time-wise? OK, I need to hurry up. Is another thing that we did. So you guys are familiar with what Microsoft calls NGen. We actually call it a little bit different. We call it ahead-of-time compilation. And it's basically, instead of taking the CIL code and compiling it into native code at runtime, you cheat and you compile that before you run, so that improves startup time. And I don't know in the Microsoft case, but in the Mono case, we generate shareable code, which means that if you run multiple processes on the system, you actually share all of that code across all processes. And we never dirty those pages. We dirty a special set of pages. Anyways, complicated stuff. But the idea here is that there's a lot of benefits to precompiling code. There's a couple of downsides. Right, you lose a register and you have a little bit of overhead on calls, but it is useful. Now the problem is that at least I believe that in Microsoft case and in our case, I positively can say so. We AOT 99% of the code, the 99% that is relatively easy to precompile. There's a 1% that is incredibly hard to precompile, and we basically punk that, and we say, well, we precompile most of the work, and for the remaining 1%, we'll just do it at runtime. Now, the problem that poses is there's a couple of platforms that prohibit the use of just-in-time compilation, for whatever reasons. My understanding from what they tell me, because I have no access to this information from Microsoft, is that the Xbox 360 has such a limitation. We know that the Wii doesn't have it, but the Xbox 360 has it. And I think it has to do with security. And the claim is that, if you were to have, downloaded content that would exploit, with modified writable pages, then you could have, a gigantic netbot, evil thing destroying the world. And I understand, because those things are all identical. It's not like every machine has different setups. Everything is identical. So, I think that the idea is to protect people. So they did not allow, native compilation. The iPhone is in a similar setup, although you never know what to believe. But the iPhone does not allow scripted languages or JITed languages on the device. It's a policy that Apple has on their license, and it's both a licensing and a kernel thing. The kernel actually does not provide support for you to turn a writable page into an executable page. So what we did is we basically had to finish AOT, which was, it was not fun, but we had to do it because it's a really interesting scenario to run managed code in these systems. So I think I should show you Mono on the iPhone. So again, we work with Unity to do this thing. Now I'm going to load a different demo because the iPhone is not as powerful as the desktop machine. So the demo that you saw, it's kind of brutal on the iPhone. So this is just a separate game. And in fact, let me hook it up so you get an idea what it looks like. And the other thing is, what I want to say, this is not a hacked system. This is a fully legit, this is a fully legit development environment from Apple. Which means that we're registered developers, and you don't need to jailbreak your iPhone. So now I can start the game, and I'm actually what I'm doing right now is this is the debug mode. What it's doing is it's running an application here that acts as a remote control, so you can debug your game live here without having to deploy, which is kind of an annoying process. So right now I'm just using the remote, and it's actually running on the Mac. And of course, the next step is to bring the application to Linux. And I can show you a couple of the things. For example, the sun rings that you see here. I don't know if you noticed, but they were spinning. Just look at the rings. As you can see, those guys are spinning in the space. Where's the? Okay, here it is. This is the script that is used to rotate it. So just somebody puts the drawing in there, and on the update tick, all they do is apply a transformation, and the rings, slowly rotate on the screen. And of course, the rotation speed is there, so you can, as I was showing you before, you can actually change that live. Where's that? That would be really interesting. Rotate speed. Never tried this one before. So let me see. So one of those must be going really fast or really slow. Oh, there it goes. That's the one that's going really fast. OK, so now I want to show you the iPhone deployment. So we go here, we go to Unity, and we say File, Build and Run. And this is going to take a while. And now you see why you actually have to have the debugging windows, because if every time you made a change you needed to do this, you would have to. Yeah, so this launches Xcode, which is the thing that actually does the code signing and it's kind of process. It does the compiling, the linking. This is actually, as I said, it already precompiled everything to native code. Copies the file over. Please work, because there's a lot of certificates involved, and if you don't have the right thing, it fails. All right, there he goes. Whew. Oh, sorry. OK, there it is, made with Unity. The cheapo edition of the product has that logo, so you get that. And there he goes, the little application running on the, well, I guess the problem is that you control like this, so you can't really see me controlling it unless you come and see it here. So how am I doing time-wise? 10 minutes? So I think I'm just going to take questions, because the other thing is a little bit kind of complicated. And it's kind of a dry topic, so I think I'm just going to skip it. So I'll leave it up there so you guys can get an idea of what it is. But mono continue. Well, I'll give you just a quick background. Remember what I showed you in the game, where the game was actually yielding the whole time? So it turns out that games really like to, they would like to have threads, but without the downsides of having threads. So that means that you never have real concurrent access. So it's cooperative multitasking. You basically say, I'm done, and you pass the token to someone else, and someone else can get work done. There's one patch that has not been included in Mono. It's one of those things where it's good that people did it, but we're not sure whether we want to include it in its current form into Mono yet. But in this game conference that I went, a number of people are actually modifying the Mono that comes with Unity to support continuations. And they use continuation to implement this micro-threading and micro-socket management for their games. So anyways, so if you have any questions, I'll be happy to take them. And I think you need to go to the microphones. Thank you.
Yeah, I just want to know how important you think it is to remain close to the state of the art with the Microsoft.NET version, because obviously it's kind of a moving target. So
yes.
How important is it for Mono to stay close to that, do you think?
I think it's incredibly important, because I think that the benefit to the ecosystem is that the code that you build on Windows will run on Unix as well. So we try to, as I said, the libraries that we build, we try to make them work on Windows as well, and we try to stay as close as possible. Some of these extensions, of course, are very specific to the CL, to us, but we would love if Microsoft would adopt those in some form. And
do you support WPF yet on Mono, or is that
we do not support WPF. We support Silverlight, though.
Okay.
WPF would just be a lot of work. Let me show you. What? Well, it's a little bit more work than Silverlight, just a tiny bit. So we do support Silverlight, and it's probably 10% of WPF. So we feel that working on Silverlight probably gives us best bang for the buck, not only because you need it for browsing a lot of content on the web, but also because the network was terrible a few minutes ago. But we can try loading some stuff, or PopFly, or actually, if somebody can, if you can come in, if somebody can help me and log into PopFly while I answer questions, that would be great. Kangaroo, thank you. So we do have that. And the one thing that we're kind of excited about is that we actually, we love Silverlight on the web, but we actually, what's going on? Oh.
This is Sarah Palin, yeah.
I had nothing to do with that. And what we did is we took Silverlight out of the browser, and we actually give you the full API. Okay. So basically, we give you .NET 3.5 with the Silverlight API. So our objective is, I mean, probably I'm going to get in trouble for this, but I would like to replace the GTK Sharp API on on GNU on Linux, right, and start building applications on Silverlight for the Linux desktop and just make them cross-platform, I think that would be
Compatible, yeah.
what? Oh, well, that's about Fly on Linux. There you go.
Awesome.
So WPF, maybe one day if we get like $1 billion to do it.
Cool.
Or you write it. Oh, that's the other thing. We are driven by contributors. So if you really feel passionate about implementing system.windows does the dispatch timer, we'll take your code.
Okay. Thank you.
Yes?
Yeah.
Over there?
Do you have something similar to C++ CLI if you want to write mixed native managed code?
Well, no, I'm afraid we do not. We do not have. It's one of the things that we've always wanted to have. It's just the scope of that project is too large. There is, though, the GNU C compiler actually has a CIL backend now, which is being written by a company in Italy called ST Microelectronics. So they do have C, and you can compile C code down to CIL. And I don't remember if it's verifiable or not. I don't remember the details. But C++ will be a very, very interesting project for someone looking to become famous in the C++ world. So for now, no, you have to p-invoke your way out or do internal calls or stuff like that.
Okay, thank you.
Yes?
Can you share any info on the debugger support for Mono?
Yeah, it's in there. Mono 2.0 shipped with a debugger. Now, you might not be very excited to know that you actually have to use the command line. So the debugger has been, kind of a we were basically trying to turn developers into real men. So but that did not work. That did not work. So we finally shipped the debugger, and we're feature complete, but it's a command line debugger. And you're probably going to be very excited that you're going to get to learn, to type, stuff like, what's this? Well, this is not the best test. Yeah, in fact, it doesn't even compile. So, for int I equals. Oh, and in fact, I have a trunk, so it's not going to work. So you're going to need to talk to. I'll show you the debugger later, but it's a very complicated story. I'm running the latest bits on this machine, and the debugger is the 2.01, but I'm running the new VM, and the VM we changed the code generator, so there's a couple of. But you basically need to use that command line debugger. It's just not going to work right now. Now. In January, the debugger will be integrated into our IDE, the IDE that I showed here. I don't have it. The mono-developed guy was. Oh, he's there. Michael Hutchinson. He's working on the mono-developed IDE, and they have integrated now the debugger into the IDE. And he can, if you come and join him, he can demo to you the debugger with a GUI. But until January, you're going to man it up.
I have a quick two-part question.
Sure.
The first one is Silverlight 2.0 compatible? Or Moonlight, I mean.
It will be.
Will be?
Our first objective is Moonlight 1.0, and that one is we're launching it in a couple of weeks. We would have launched it before, but marketing, both it's a joint collaboration between Novell and Microsoft. So the marketing groups have decided when that gets launched. So. The Moonlight beta will be available in a couple of weeks. I don't remember the date. And it will be 1.0 compatible. But we do hope to have a 2.0 preview. I mean, we just don't know how stable or complete it's going to be by mix. We basically had to suspend work on 2.0 when it's complicated. When we got the codecs from Microsoft, and we had to port them, and anyways, but we'll have 2.0 by mix, but 1.0 is coming out in a couple of weeks. So at least you can watch Channel 9 and play Pop Play, kill moose.
Is there any thought of porting the DLR to Mono, or would that just be redundant?
That's actually, no, it's redundant because the awesome guys at Microsoft sitting in the front row and everybody else involved actually managed to get the DLR and IronPython and Jim Hugunin and all of those awesome guys got the DLR and IronPython, Iron Ruby under the MSPL, which is an open source license. So we just incorporate that code, and we're very thankful to Microsoft for doing that. We love them, of course. So it's not limited.
as you kind of already hinted, I mean, some of us probably have not failed to notice that we're not in the hotel room this time.
You're another one. Oh, yeah,
We're
that's
not-
right. Yeah.
Would you comment a little more about the relationship between Mono and Microsoft?
Well, so I think that, we were always an open source project, and when the Novell-Microsoft agreement, of the collaboration agreement happened, it actually opened a lot of doors in terms of being able to talk to a lot of people at Microsoft and, and getting to meet them personally. I've met a lot of the hackers that are in the front row. This side is the Microsoft side, and that's the Novell side, and I thought that they should mingle, but anyways. So a lot of my friends, I've met a lot of friends at Microsoft over the year, but never really a lot of people in management. I think that the collaboration helped a lot. It's something that the open source community, had a heart attack over, but it has been incredibly helpful, and without that, I don't think we could be doing Moonlight, and I think, and Microsoft now MSPLs a lot of things actively. I don't know if you saw the MEF announcement, but MEF used to be, Windows only. They changed the license to MSPL. A lot of the controls that are built for Silverlight, which would be, it would take us years to implement. It's just there's so much work. They're actually MSPL. The Silverlight toolkit controls that were announced yesterday were also MSPL. So the reality is that it's great. I think Microsoft is seeding the market with a lot of open source code that people can cut and paste for their own uses. We're going to use it for Moonlight. And I forgot what the question. Oh, thank you. Oh, Brad, thank you very much. Brad, Brad Abrams, the author of the .NET Framework Guidelines. Thank you for coming. So
you showed a little bit of the iPhone development stuff with Unity.
Yeah.
Can you expound more on what the full development experience is like? Do we have to use Unity, or can we now use C#?
So Unity was very aggressive in terms of getting their iPhone games for the iPhone, because that's what they built, and they really thought that there was a market there. So we work with them very closely to make that happen. We are really, we're Linux people. So, we'll help them because we really like them and because it demos very well. But it's not really helping Linux because all of those games run on Windows and the Mac. It's not really our thing.
Sure.
We wish that it run on Linux, and, they gave us access to their source, so we'll eventually port Unity to Linux, which is the good news. So, I'm not completely heartbroken. But as for bringing .NET applications to the iPhone, it's something we want to do. Is just we haven't ourselves spent a lot of time on it. There's one thing that I kind of omitted, that I didn't really mention, which is the version of Mono that runs on the iPhone right now. It's limited to the 1.0 profile. Only last week we finished support for generics, which were a lot harder to get statically compiled. So our interest really is 2.0, and we would like to make it possible to take one of the possibilities is taking a ZAP file from Silverlight and running it on the iPhone. All right. Yeah, so we would like to do that. But I don't know when it's going to happen. So, in our copy of spare time. Or you can help out, join the yes.
How interoperable are the Mono and the standard Microsoft development stacks? Can I build against Mono libraries in Visual Studio? Can I incorporate the Mono runtime into my Visual Studio debugger? Is any of that possible? Is all that possible?
So you can't really, you can't really use Visual Studio to debug. If you embed Mono into your application, like host it inside your application and try to debug Mono code, I don't think that's possible. You're going back to printf. And in fact, our debugger doesn't work on Windows. We just don't know enough Windows to port the debugger to Windows. But the rest, if you build in Visual Studio, the executables will run on Linux. And if you build our compilers, you take the executables and put them in Windows, and they will run. There's really no difference. Same with ASP.NET. You drag and drop the folder. There's one caveat, which is if we have not implemented the API, then your code will not run. Now, luckily, I didn't talk about that today, but there's a tool that you can run on our website that will inspect the DLN and will tell you, well, these entry points in Mono do not exist, or they have semantic differences between Unix and Windows, or they're not implemented. So we'll give you a report. And in that particular case, it would help you migrate your application. And in fact, you can optionally submit the data to our database, and then we aggregate all that data, and we get a list of what are the most important APIs to implement, and we go basically in that order. So we prioritize the most used APIs and the ones that nobody uses,
That's really neat. So if my development environment is constrained to be Windows, but I want to ensure that my applications will be safely cross-platform, I can just take the Mono libraries and ensure that I only reference them and not sort of the standard .NET stack, and then things will be fine?
You could do that. Yes, you could do that. That's one option. The other one, I mean, honestly, I think that you should, it's not only about the linking stage and making sure that you compile with those. I think that you also need to test them. I mean, I think that anybody... What? I'm a test guy, you know, you need to test your software. So, you know, maybe there's a bug in Mono, who knows? I don't think so, but if there were a bug, I would test it before.
In your Moonlight support, you have support for reading and writing for XAML to get the, the controls and everything working, is that right?
Well, we have a C++ XAML parser, and I don't think we have a writer. No, we don't have a writer.
Okay, so you're just using it for reading in, and do you have any support for BAML, the like binary compacted version?
No, I don't think Silverlight has it, so that's why we haven't implemented it. But you know, it's a nice challenge for someone that would like to contribute code.
Okay. Great.
But you know, we're gonna go hang out at Meet the Experts because we also want to meet the Microsoft guys. If you have a lot of questions, we can take it there later, and we can probably discuss BAML. You know, Chris Toshak here, you know, on his copy of spare time, implemented Silverlight on JavaScript. You know, it's a good hack. You should go check it out. We love you. We love you. I love you. Sorry. Yes?
Building on the question.
Yeah.
What about your dynamic compilation? How cross is it? Does that work on Windows?
Yes.
Would that library specifically work on Microsoft's
It works on Windows.
runtime?
There's a couple of tweaks that there's a couple of tweaks that we need to make because right now we're using a couple of APIs that are only available on Linux. So you have to compile with a special flag, and some features are disabled in generics because reflection emit is not complete enough. So we're working on a workaround so they will also run in the .NET framework. But they're like tiny little features that there are only tiny differences in C# on what's supported on both platforms.
Okay.
And I think we really should go. So this is the last one.
Yeah. Now, I just wanted to mention, I don't know how many of you here use test-driven.NET to run your unit test in Visual Studio. When you install Mono in Windows, you get a new command, which is test in Mono. And so you can run your unit test for your .NET assemblies with Mono. So if you're using APIs that are supported in Mono, the tests will pass. Otherwise, it will fail horribly. But you can get
that's awesome. That's awesome. What is it called?
We tried it earlier today with Jamie Canstel. He's the guy who did test-driven.NET. The only unit testing framework that we tried and works is NUnit. So I was using XUnit, and I couldn't get it to run. But with NUnit, it runs just fine. So.
Well, we should fix NUnit anyways. But thank you very much. Thanks for coming.